Calculus! Calculus lesson 8-3, specific FTC applications. So, using FTC, what is FTC? First of all, anyone want to take a guess? It's the most important rule, the most important theorem in all of calculus. This is the big guy, the big guns. No guesses, no guesses. It's a hard one to know, so I don't expect you guys to know this yet, but it is called the fundamental theorem of calculus.
Oh, makes sense.
Where's the O?
Fatak. We need an O in there. By the way, today's date is January 24th. It is a Thursday. We're going to end the unit with 8-4 on Friday. And then we have a bunch of self-checks. Technically, we have 8.8 if we wanted to do those. And then the test. So theoretically, we do Monday, Tuesday, Wednesday, Thursday, Friday, which means the next coming Monday would be the Unit 8 test. All right, so coming back to, that's the wrong notes. There are our notes, fundamental theorem of calculus. So a little bit of history on calculus. Back in the day, we didn't actually have a very good understanding of what infinity was. We call it infinitesimals. So we wouldn't have these strict definitions, which we still don't technically need until you get into this really weird high-level math. But we had two fields of calculus. One was integration, one was differentiation. They were totally separate fields, no connection at all, until the fundamental theorem of calculus. It says, hey, going forwards is taking the derivative, going backwards is taking the integral. That is the fundamental theorem of calculus. It connects those two realms.
Another vocabulary.
So fundamental theorem of calculus, you can use FTC whenever you need to say fundamental theorem of calculus for now on, even on the AP test. You can say by FTC, you do this and this and that, although I don't think you actually ever have to do that. But anyway, it's the same formula that we've been using, but we're going to be using it in a slightly new way. So that same formula for total change, do we remember it from last unit, Unit 7? This plus this equals this. Start.
The integral.
Start plus.
Start plus change equals that.
Yeah, that's it. It's the same formula. We're going to use it in a different way. Start plus change equals n. It's going to be using, this change is now going to be using the fundamental theorem of calculus. So we have the same problem. I changed it now. And this is not something that I should have changed a long time ago. I'm changing it for the specific purpose of using the fundamental theorem of calculus. So now instead of the can starting empty, it's going to start with some water. It's 10 millimeters high of water, to be specific. And our equation used to be 2 sine of 0.03t. And because I've added some water, it's better modeled by this function where I add 1.5. Those are the only changes. So far, so good? Nods our heads, lets you know that we're awake. All right, so Arrow is asleep and everyone else is awake. We go with this. You did nod your head. This is our can that we're talking about. So let's use the information from this problem. What do we already know about this can before it even starts raining? It starts at 10 millimeters. So technically, there's this meniscus line, so I guess you draw it like this. It should be a curve. Although if you want to be less fancy, if you don't want to be pedantic, that's our lovely word in math class. If you don't want to be pedantic, then you can just do a straight line across. I'm okay with that. But at 10 millimeters, that's where it starts. So I'm going to label that as start. And if you want to shade it in because you're being fancy too, that also is cool. Let's go ahead to our two questions. How high will the water be after 5 days? This is our old question that we should know the answer to.
Should it be the integral of 0 to 5?
Integral from 0 to 5, you're correct, of
S prime of t.
Of s prime of t, s prime of t. And then we'll add a dt to be formal.
Plus 10.
Aha! Plus 10, because it's start plus the change is equal to the end.
5 instead of t.
Oh yeah.
What's up?
We should do s prime of 5 instead of s prime of t.
No.
Well, because we already have the integral that says from 0 to 5. So that's how we know that the bound is going to be
okay.
between 0 and 5 days. What is s prime of 5? Speaking of, what does that represent?
The area between 0 and 5?
No, because we don't have an integral. So it's just alone. This is the question.
Total change between 0 and 5.
Nope. Good guess. S prime of 5. What does this thing mean? S prime of 5. Well, what is S prime, first of all? Think about that in your heads. And then what happens when I substitute 5 into that function?
Is it the height?
It's not the height.
It's the rate of change at t equals 5.
Yes. And in the context of the problem, what does that mean?
What is the rate when the water is? What's the rate of 5 days when the water is high?
You're really close. You just kind of flipped your words around. Anyone else want to try to get that full English sentence out? I think you guys are getting the point, but you don't have the full sentence that I'm looking for. S prime of 5. In context of the problem, Ben already said it correct symbolically. It's the rate of change at time equals 5. But what does that mean in the context of this filling up of a can problem?
What's the rate when
The rate of what?
the rate of t equals 5?
We're filling a can. So it's the rate of the height change. How fast is this thing going up at
10 millimeters. 5 days.
at 5 days? So on the 5th day, how fast am I going up? That's what this thing means. All right, that was some fun review. Maybe fun is not the right word, but some definitely review that we needed. So let's go ahead and calculate that. Pull out your calculator. Wabbit, EMU, and we're going to open my emulator. We're going to change our equation now, so y equals, it's going to be 2 times sine of 0.03x. That's going to be plus 1.5. And I don't need to delete that actually. And then my window is going to be, I guess 0 to 60 is fine. Zoom 0. If you don't want to do it graphically, obviously there are different steps. I think Ben was doing it non-graphically for the homework from what I saw yesterday.
Yeah.
And that's totally fine. All right, so if I want to find the integral between 0 and 5, I do what? Some review. Tell me what to do. Second, trace 7. Second, trace 7. That is the integral between where and where?
5.
0. 0, enter, 5, enter, and it should shade in whoop, that little bit. I got 8.2485, blah, blah, blah. Is that what you guys are getting?
I got 249. Like it's 8.249.
Yeah, rounded. So this is 8.249, still adding to 10, which gives us
18.249 millimeters.
9 millimeters. Yes, correct units. We are in millimeters, not millimeters per day, because we have gone backwards from this rate. Going backwards.
How do you know when to put millimeters per day?
Millimeters per day is whenever you're asking for a rate. So if I was asking for S prime of something, like S prime of 5, that would be millimeters per day, because that is a rate, because it has a prime. Although sometimes they just give you a function E, where that E represents a derivative. In that case, you are still using the prime. It's not always when the prime, it's whenever this function represents a rate. That's a good question. All right, so this is the really big question. I should have given it a star already. Give it a star right now. Practice how good are you at making a star. This is the most important question from today. How high will the water be after T days? A variable number of days. I can choose whatever number I want and I'll get the correct volume, the correct height.
Are you trying to find when it equals 10 millimeters?
No. But we do start with 10. We always start with 10, right? Can we all agree that?
10 plus integral from 0 to t, s prime of t dt.
It is 0 to t. Instead of 0 to 5, it's 0 to t. We replaced this 5 with a t, just like we replaced this 5 with a t. So 0 to 5, s, come on now, s prime of t dt. And what is this thing actually equal to? This is the same thing as writing s of t. That is s of t. That represents the water height. We always started with s prime of t. S prime of t is the rate of the water height. But by using the fundamental theorem of calculus, by doing this rule where you go from 0 to a variable for your integral, you have now gone backwards to s of t. That is s of t right there.
So 10 is like the constant of integration. It's like that 10 gives you the constant that goes away when you take the derivative of s of t.
Yes. That's part of it. It's not quite the same way, but it is an initial condition. So the answer in a very simple statement is yes. And that comes from, they could have given you that form like this. They could have said S of 0 is equal to 10. Can we all write that in our notes too? That's another way of saying that your initial condition at time is equal to 0 is 10 millimeters. So that's your initial condition. And as Ben said, the way to think about that is your constant of integration, that they are telling you, hey, that C at the very end when you take the integral is actually 10. All right, that's all I got for you guys. Are there any questions on this lesson? All right, that concludes the lesson. Go ahead and write your summaries now, and then you can begin on the homework.